So as a summary from the activity, the Pythagorean theorem is a relationship which only involves right triangles. In other words, triangles that have a 90-degree angle. And the relationship is the square of the hypotenuse, which in this case is c squared, is equal to the sum of the square of the other two sides. So we can write this one of two ways. We can write it as a squared plus b squared equals c squared, which we saw in the activity, or we can write this the other way around, which is c squared equals a squared plus b squared. Now, an important thing to note here is that it's important that you identify the hypotenuse as c. And it doesn't matter which side you identify as A or B. We can interchange A and B. It doesn't matter which we assign. And just to show you how this works, what we're going to do is sub in for side B is equal to 4 and side A is equal to 3. And so when we do that, we get 3 squared equals 4 squared. 3 squared plus 4 squared equals 5 squared. And 3 squared is 9. 4 squared is 16. And 5 squared is 25. 9 plus 16 is equal to 25. Now, if we had to sub this in differently, and in this case, what we're going to do is we're going to sub in for b equals 3 and a equals 4. Then what you would get when you sub into a squared plus b squared equals c squared is 4 squared plus 3 squared equals 5 squared, which is 16 plus 9. And it doesn't matter which order you add them in. 16 plus 9 is the same thing as 9 plus 16. So again, it doesn't matter which of the legs you sub in for as a or b, but it does matter whether that you identify the hypotenuse and sub in for the hypotenuse correctly. So now if we're going to take a look at how we can use the Pythagorean theorem, the Pythagorean theorem can be used if we know the lengths of two sides in a right triangle and we're trying to find the length of the unknown side, or the third side. And so as an example, we're going to try and determine the hypotenuse in triangle ABC. And this is just like what we had just seen. And so now we're going to go through and solve algebraically and show how you would do all the steps on a test or an exam. So first you identify the hypotenuse, and the hypotenuse here is side AB. And so we're given here this side, which is BC, and we're going to call that side A, and A is 3 centimeters. We're also given the other side in the triangle, side CA or AC, it doesn't matter which way you say it, and the length of that is 4, and we're going to say that that is B. We could have switched this around again. It doesn't matter whether that you assign the 3 centimeters as A or B, or but it does matter that you identify the hypotenuse as side C. So what we require here is the hypotenuse, or side C. So we're going to use a formula, and our formula is c squared equals a squared plus b squared. And we're going to sub in for a equals 3 and b equals 4, and we get c squared equals 3 squared plus 4 squared. Now we can solve the equation. So c squared equals 9 plus 16, and 9 plus 16 is 25. Now, in order to, if we've got our given c squared is equal to 25, we have to take the opposite operation, and the opposite operation of squared in order to isolate the variable is the square root. So now we have to take the square root of both sides of the equation, and the square root of c squared equals the square root of 25. So to do this on a calculator, you input 25, take the square root, and the square root of 25 is 5. So that means that the square root, c is equal to 5 centimeters, because the square root of 25 is 5. And so therefore the hypotenuse of this triangle is 5 centimeters.